About 10 minutes. Okay, about 10 minutes. Okay, 10 minutes. 10 minutes. As soon as it's done, what do? Pull it out and you throw it into cold water, or you can put ice on it or whatever, right? This makes it easier to peel. Okay, also make sure that you do not have a soft boiled, half boiled egg. All right. Those are, unless you're making it for ramen, it's not good to have. If you want to make it for ramen, that's a good thing to do, right? Okay, so remember when we talked about that, we said that the driving force of how quickly it'll cool was what? So I have water here, I have the egg. I have water at temperature, I don't know, 20 degrees Celsius. The egg comes out from 90 degrees Celsius. What time, what temperature does water freeze at?
0 degrees Celsius.
Yeah, 0 degrees Celsius.
That's like 50 degrees.
Yeah, this is not really cold water. It's cold enough.
It's like lukewarm.
Yeah, it's lukewarm. Yeah. So anyway, so what is driving the cooling mechanism? It is the temperature difference, right? There's a temperature gradient. It's the temperature difference between your egg and the cooling medium. Okay, all right. So remember the equation was no. Just remember, this ring your bell? This ring your bell? The temperature of the egg at any given time is the temperature of the water, the temperature minus the water, right? The temperature of the water. That's the temperature gradient or temperature difference, right? At any time t. This is the temperature gradient or temperature difference when it first goes into the water. Okay. And it's going to exponentially decay away. It's going to go smaller, right? But the temperature difference is going to, as the egg cools, you have less and less temperature difference, right? Which means that it's going to cool at a slower rate as you go along, right? Okay, so let's look at the example there. Let's look at the example of 6. Let's do example number 6. Let's do example number 6. Example number 6, we have a hard-boiled egg at 98 degrees Celsius. Not 90, it's 98 degrees Celsius. Put in a pan under running water of 18 degrees, not 20, 18.
That's more believable.
Okay, so after 5 minutes, the temperature is found to be 38. Okay, so what does that tell you? What are they trying to tell you?
5 minutes.
So at 5 minutes, e to the, I don't know what this is, 5 minutes, I started out at 98 minus 18. I'm going to end up at, was it 38? 18. So I can solve for everything. I mean, there's the only thing that I don't know is K. So really what they're giving you is they're giving you a mechanism to solve for K by giving you this information. This information is giving you the value of K. Okay, so 20, 80, divide by 80, right? Natural log, 5K jumps forward. This guy is 1. So this guy divided by 5 is correct. That's guy. So that's giving you what they're doing is they're giving you K there. If you do that, K is 1/5 of natural log of 4. Okay, so again, my K is going to be negative because of the way I put it here. Okay, K is going to be negative. My K is going to be negative here. K is going to be equal to 1/5 natural log of 1/4, right? 20 minus 80 is 1/4. This is the same as negative, right? 1/4, right? 4 to the -1. Okay, so that's my k. So in other words, I'm going to go ahead and find that this is going to be -1 t. This was 18. This was 98. Right? Question is, what was the question? How much longer will it take for the egg to reach 20 degrees Celsius? So we'll just go 20. I can solve for t, correct? Right? All right, so that's how you do Newton's law of cooling. Let's go to example number 4, choosing a base. Number 4. Oh, why is this board dirty today? Example number 4. At the beginning of the summer, the population of a hive of bald-faced hornets, oh my gosh, which are actually wasps, is growing at a rate proportional to the population, which means that it is an exponential growth, right? Exponential growth, which means that it is going to fall into this. Okay. From a population of 10 on May 1st, the number of hornets grow to 50 in 30 days. So starting from 10, then it became 50 at how many days? 30 days? But would it be K? No, it wouldn't be K. No, it wouldn't be E. So we would rather do 5, right? So I'm going to choose the base as being 5. So I can choose the base whatever I want it to be, right? I can choose the base whatever I want it to be because all that does is a K would change associated with that, right? K would change associated with that. That's a T, right? Because when T is equal to 30 days, right? T is equal to 30, and you get 30 over 30, which is 1, times 5 times 10 is 50, correct? Okay, so I'm kind of backfitting this, right? You understand how I'm kind of backfitting this here, right? So that's that, and if the growth continues to follow the same model, how many days after will the population reach 100? So how much time will it take this to become 100? Right? Divide both sides by 10? You know, right? 6. Natural log of both sides. Right, so I'm going to get natural log of 10 is equal to T over 30, natural log of 5, divide by natural log of 5, that goes away, multiply it by 30, that's your T. So the key to solving this problem was what? Not using this guy, but using the 5, right? Why did I use the 5? Because it started from 10 and went to 50, right? So the growth factor of 5, which that's what made me use the base of 5. Okay, so that's the key. Right? Okay, we're good, we're done. We are done for the day.